Hello, in this video I will create a level angle gauge or inclination indicator for my truck model 2023. And here it is, my highly sophisticated off-road truck. Whole project may look a bit complicated, but don't worry. I'll go step by step to make it easy to build. So let's move forward. Job done. Very funny. What we will need for this project: Raspberry PICO, MPU 6050 module or similar. Of course, you can use one OLED display, but I was wondering if you can actually connect more than one display to PICO, and as I couldn't find it on the internet how to do it, I've done it my way, so no guarantee it is the right way. I decided to add two buttons, and I will explain why as we go. Of course, you will need some cables and breadboard for easy connections. I will not show in this video how to connect PICO to your computer and make it recognize in Sony, as there are tons of manuals on YouTube. But if you are having troubles with it, let me know, and I'll maybe add some video, maybe even with a way to flash your PICO after a total crash when Sony is not able to recognize it anymore. Let's start. Here is my PICO connected to my PC using Sony. First of all, we'll need some libraries for displays, MPU 6050, and maybe some fonts and so on. All of them you can find on my website together with the wiring diagram and full code. My understanding is that libraries in programming are like drivers for components which you have connected to your computer, and without them the device is not going to work properly or at all. So download all necessary libraries and code. In some of them you can find a description from the creator and GitHub link if you want to check for updates. As I started with PICO, I was madly downloading every possible library I have found on the internet. So I'm not sure which belongs to whom, but if you will download all from my website, it will work, and inside some of them you can find the original creator. Now, find the folder you saved all libraries in your computer and upload them to your PICO by selecting them, holding Ctrl, then right-click and select Upload to. Keep all files in hierarchy which you download them from MicroPython to work correctly. If you know what you are doing, you can connect everything according to the wiring diagram, upload to PICO file OLED final PY, and you are ready to go. But if you are a beginner and you want to learn something step by step, upload to PICO file OLED start PY. You can switch off your PICO now and let's do some manual work. First, connect SDA pin of first OLED display to GP6 of your PICO. Then connect SCL pin to GP7. These two lines will represent plus and minus on your breadboard, or I think they are called power rails, with some joints where we will connect some cables later on. Connect plus rail of your breadboard to 3V3 pin of your PICO, which stands for 3.3 volts, to share the power, and minus rail to the GND pin, which is ground. Now connect the VCC pin from the display to the plus rail, and finally GND pin of the display to the minus rail. Let's connect the PICO to your computer and do some programming. Double click on file OLED start PY, and here we have a basic code. I'll try to explain what I know. I hope I'll be right. First of all, we need to import some drivers, or in microcontrollers world, libraries. So from machine, which is your PICO, import pins, and I2C or I2C, which we will use for connecting all components and time. And as we also need libraries for display and some fonts, we will import it from the OLED folder. We don't need all of them for now, but just import them all. Next, we define OLED width and height in pixels and tell PICO on which pins is our first display connected. Plus, I created two variables and defined bigger, write 20, and smaller, write 12 fonts for the OLED 1 display. And now we are ready for some fun. Use command while true, which means it will run until the condition is true, in this case forever until we'll cut the power for the PICO. Use a bigger font to write hello on the display at position, for example 20 from the left side and 33 pixels from the top of the display. Just to mention that the top left corner is basically 0 position. First number is X and second Y axis. Give the first display command to display hello, wait 1 second, delete the display and go to the beginning of while through command, with capital T of course, and so on. Press the green arrow button or F5 and on your display you should see hello. Magic! It will be a different font of course compared to what you can see on my screen. Let's go on. Press stop and disconnect your PICO and connect another display if you have one or you want to connect another one, because you can use only one display if you want, and connect it like this. Pin SDA of your second display goes to pin GP14 on the PICO. SCL connect to GP15. Give it some juice by connecting VCC to plus rail of your breadboard and GND to minus rail. And connect PICO back to your computer to add some more rows in the program. In Thony, add these rows to identify pins and fonts for second display, which can be different compared to the first one if you want. Copy the row 23, but now use font defined for second display to write text world. Add command to display it, and after 1 second delete the second display and go back to while condition. Press the green arrow and here it is, the most famous sentence in programming ever. Hello world. And not on one, but 2 displays together. I just love it. In reality I've got my displays the wrong way around, but it doesn't matter. We just need to connect the MPU sensor and we will be almost ready to use it. So press stop again, disconnect the PICO and get your MPU sensor ready. Connect SDA to the pin GP16, pin SCL to the pin GP17, and again VCC from your MPU goes to plus and GND to the rail minus of your breadboard. Connect PICO to your computer and jump back to Thony. Here I added the condition defined for the MPU sensor, which as we already know is connected to pin 16 and 17. And of course, we must not forget to add a new library for our sensor, otherwise PICO will not recognize it. So add this row. Let's add some conditions to read and display values from the sensor. Here are all readings assigned to variables XYZ axis for level, XG, YG and ZG for gyroscope. Of course you can use your own names for variables. And T is for temperature reading that we can show on our displays. For demonstration I will use XY and maybe temperature only. So add these lines. Wait, a little bonus. I will use command print to show all readings on screen instead of displays. So add this code if you want, or just watch it for fun. Or maybe easier version. And press the green arrow. Now the PICO is reading all values from the MPU and we can see them on our screen. You can see that on displays it's still our favorite sentence, "Hello world." Let's change delay to 5 seconds for easy reading and press F5 for restart. And you can see both commands show the same result. If you tilt or move the sensor, you will see all values will change. As it is hard to see it, I will make some changes. First of all, as I mentioned before, I'll use only the X and Y axis and the temperature reading for smarter results. So I'll delete this row and the gyroscope reading. For an easy reading, I will round X and Y to 2 decimal places and temperature to 1. Press F5 and you can see now much better how values are changing when I move the sensor. I can even make it look smarter by adding R for return at the beginning and end of print command and press F5 again, and all values will be displayed on the same row every time. Nice. Now it's time to use our displays. For start, just change "Hello World" to X and Y values. Don't ask me why, as I don't know the answer, but for display commands we have to use string even if it is number. So I'll change it to string. Press F5 and you should see on your display X and Y's readings from MPU instead of "Hello World." And if you move the sensor, you can see they are changing. At this stage I thought all was done and I can use it for my car, but you can see that these numbers don't tell us much. Now it's better to set the time slip back to 1. If you move your sensor by 180 degrees from pointing left to right, you will see that the reading comes from -1 to +1, which has nothing to do with degrees. And I'll remove the round from the print command as well to see exactly what is on display. I'm not worried about the temperature, which is not going to be displayed. On displays you can only see X and Y. And my thinking was, if I multiply the reading by 100, I will get readings from -100 to 100. So 90 degrees tilt will be equal to reading 100. Then I just need to divide it by 90, as it is 90 degrees, not 100, which we use. And I'll get the right factor to have output in degrees, which is 1.11111. I hope that's right, but these have to be in brackets. You can try it by pressing F5 and you will get reading in degrees. But as I want this number to be integer, I'll add int at the front, and all these needs to be in brackets. F5, and now you'll get reading we need. And do the same to the other value. In case you will need to use the gyroscope readings, change it to integer if you want. There is a bit different story with the temperature reading, as we use at least one decimal place for that, so leave it to one decimal place. Now I'll jump a bit. I'll pass this code and just explain any changes. So, small font for first display will show the gyroscope reading of X and Y in position 15 from the left and 5 from the top of the display. You can actually draw the line, but I just used underscore to add another row in position 15 by 15. Big font for first display will show Y reading, and just for fun, another line. Now the second display. Small font in second display will show the temperature reading, line, X reading, and another line. F5 and the beauty is here, and we are almost done. Almost. Now I was thinking, what if I'll mount the sensor in my car and it will not be in a perfectly leveled position? I'll get wrong reading of my car position all the time. I will have to remember what the difference is after I'll place it in the car and add or take away the value. But what is the difference? Simply too many questions, and for that sake I decided to add two buttons. First button will set my reading to 0 when I'll be on nice leveled car park or so, and I can use the unit perfectly fine with the right readings. And the second button will reset the sensor to its default position in case I'll need it. To be honest, I'm not actually sure if I will. Anyway, let's connect our buttons to the PICO. Press stop and disconnect the PICO. One button will be the level button, which will set our value to 0 in every position. So connect it to the pin GP22 and the other side to plus rail of your breadboard. The second will be the reset button, as I mentioned before, which will go to GP21 and plus rail. Connect the USB and back to Thonny. Now let's define slot I decided to connect our buttons to. I'll just paste the code from my origin code and I'll talk a bit about it. So the level button is connected to the pin 22, which is the input type, so PICO will read from that slot with the pull down definition. And what does it mean? Basically, if we have a switch connected to a microcontroller, in this case PICO, as we do have, and the switch is open, we would think there is a 0 volts on our input. But in real life it is not. Instead it's floating, so it can pick up random signals or noise, which is not really good, as it can confuse our microcontroller. And this pull down definition, which is the same like we would physically connect a resistor to ground, will give us a complete 0 volts on our input, and if we press the button there will be 3.3 volts. That's what we need. There is also pull up definition, which we use if there is the input connected to ground instead of 3.3 volts. And there is the same definition for the reset button, except the fact it is connected to the pin 21. We need some constant or factor which we will use to reset our level to 0. So I added two variables for X and Y readings, which is set to 0 as default, or in case we press the reset button. These are basically readings which PICO will remember when we press the level button and take away that value from an actual reading. Now simply add it to our X and Y readings. And the last step is to add some definition for PICO, how to behave when using our buttons. Add it somewhere between basic definition and displaying our values. I'll just paste it in to not make any typing mistakes, as I'm not professional yet. So if you press the level button, the factor will remember the actual reading and take it away from the X and Y variables, which will set our display value to 0. We can press the button anytime, but the best is to press it after installing the level gauge in our car when the car is parked on a nice level, like a car park or so. As I mentioned before, it is hard to mount the gauge exactly in the right level in a car. After that, our gauge should work properly and display the actual readings. Well, at least the factor plus an actual reading is not higher than 100, but about it maybe later. And if for some reason we will want to reset the factor, simply use the reset button and the factor will be set back to 0. That's it, all done, ready to use. Oh yeah, I forgot to mention that you have to keep holding any button longer than you set your time sleep, as the while loop needs to run the whole code. The solution would be to use a command which jumps to other code when the button is pressed, but I wanted to keep it as simple as possible. If you like the video and you want to support me or just buy me a chewing gum, you can do it on my website. And don't forget to subscribe. Maybe I will have another video for you. Take care and enjoy your new level gauge. Bye.